Okay, so we're talking about inscribed angles, and this is section 12.3. So we're going to take a minute to take a look at this figure right here. In this circle, we have an inscribed angle, angle ACB. So we have angle ACB, and then we have intercepted arc AB. Okay, and if we remember correctly, an angle um, formed with all 3 points on the circle is an intercepted arc, or excuse me, is an inscribed angle, and an arc that's created by the inscribed angle is the intercepted arc. So we have the intercepted arc right here and the inscribed angle right here. Um, we have this relationship with the inscribed angle and the intercepted arc. It creates a relationship that is the inscribed angle, which we're going to use this picture right here to show. So the measure of angle 2 is going to be equal to 1/2 of its intercepted arc, which in this case is arc CD. Okay, so if we were talking about the arc, if we want to find the arc, then we would say arc CD is going to be equal to 2 times the measure of angle 2, which is just the reverse of that particular formula. So if we look at this problem here, we have inscribed angle ABC, and we want to find the intercepted arc AC. So we're going to say that AC is going to equal 2 times 70. Okay, so AC would equal 140 degrees. Okay, so then if we move over to this one here, um, we can use the given arcs to find the angles with them. So if we first talk about angle BAD, the intercepted arc is going to be 100 plus 90. So half of that is going to give me 95. And then if we say CBA, this is going to be 90 plus 64. And half of that is going to be 77. And if we are talking about BCD, then that intercepted arc is 64 plus 106. So half of that gives me 85. And then if we talk about CDA, we're talking about 106 plus 100, and half of that is going to be 103. So if we add all those together, 77 plus 85 plus 95 plus 103, then we should get 360 because the sum of all the interior angles for quadrilateral would be 360. The next relationship that we have to talk about is a corollary to this theorem, which means it's basically just something else that we know because of this theorem. And this is that angles with the same intercepted arc are congruent. So if we look at this one right here, and we can say, if we said angle EFH, then we know it intercepts this arc right here, EH. And then if we say angle EGH, or angle 4, it also intercepts the same arc. Okay, so what we know is that angle with the same intercepted arcs are congruent. So therefore, what we can say is that angle 3 is going to be congruent to angle 4. Okay. Um, we use another one over here where we're trying to find first the arc here, A. We take this angle PQT. The angle is 60, and we're looking for A, and we know that A is going to be equal to twice 60 because of the theorem that we have. So We can say that 60 is equal to 1/2 of A, or we can say A equals 2 times 60. Either way, A is going to equal 120. And we look at B, we now know that A is 120, so we fill in 120 here. And we look at B, and B is the angle here that has this intercepted arc, 120 plus 30. So we do that, we can say that 120 plus 30 is 150. And we know that B is going to equal 1/2 of 120 plus 30, or 150. So B is going to equal 75 degrees. So this will be 75 degrees. The next corollary that we have for this theorem is that if an intercepted arc is 180, or a semicircle, then we know that the inscribed angle is 90. Okay, so if we look at this and we say the intercepted arc here is a semicircle, or its measure is 180, then if 5 equals 1/2 of 180, then 5 has got to be 90 degrees. So therefore the measure of angle 5 is 90 degrees. So if we look at this one, this is 180. This is a diameter here, so therefore that tells us that 3x must equal 90. Therefore x is going to equal 30. Okay? And the last corollary we have for this theorem is that opposite angles of an inscribed quadrilateral are supplementary. So we say, okay, well, if that's the case, then we know that measure of angle 7 plus the measure of angle 9 equals 180, and the measure of angle 6 plus the measure of angle 8 also equals 180. Okay, so we'll use this corollary to solve this problem here. And we'll say 9y plus 22x, or excuse me, 19y plus 22x has to equal 180. And we'll say that 10y plus 40x has to equal 180. Okay? And if you remember from your Algebra 1, we're going to have to use a system of equations because we have two. So if we say 19y plus 22x equals 180, and we say that 10y plus 40x equals 180, then we can say because they both equal 180, we can set them equal to each other. So we end up with 19y plus 22x equals 10y plus 40x, and oops, don't have to put two equals, so I don't know why I did that. And then from here, we'll just solve for one or the other. So I think I'll go ahead and solve for y. And I'll first start with, oops, okay. So I'll do that by, okay, not sure why that's doing that, but let's try one more time. So I do that by subtracting 22x from both sides. And then I'll get 19y equals 10y, and that's going to be plus 18x. And the next thing I want to do is subtract 10y from both sides. And it looks like I'll get 9y equals 18x, and then I will divide by 9, okay, and I get y equals 2x. Now, from here, I need to plug this into y, so I'll go back over here and I'll say 10 instead of y. I'm going to say 2x, because again, y is equal to 2x. And then I'm going to say plus 40x, right, equals 180. So that's going to give me 20x plus 40x equals 180. And that's 60x equals 180. So x is going to equal 3. Okay. Now, to figure out what x is, I need to plug x into any one of these three equations. So I'm just going to plug it in here to find y. So y equals 2 times 3, which means y will equal 6. Okay, so the answer here is going to be 3, 6. Okay. And that's using your Algebra 1 systems of equations. And method is substitution. So if you need to look it up to get some practice, you're looking for solving systems of equations by substitution. Okay, and the practice problems for this section can be found in section 12.3, and they look just like this.